What do you get when you combine a Steinberger Headless bass with a Guild B302, with a Music Man Stingray 5, and a Rickenbacker bass? Something like this. I wanted to build a bass for myself that encompassed features I admired in my travels in guitar repair. When banging ideas around in my head, I started with making a visual mock-up, cutting and splicing various ideas together like Frankenstein. Okay, this is the lighting system for my fret markers on this headless bass that I'm making. Okay. Let's see what's going on there. This is the driver. It's a single LED. It's used for automotive purposes. It'll run on 9 to 12 volts. And it's just one LED, so if it ever goes bad, you can just replace that. And you don't have to mess with all this stuff up here. There's a single fiber optic traveling all the way up the neck here. And it is programmable, this tiny little chip that I've hacked to replace those little click switches on the side with push-pull pots here. See? And these pots, the rotary part of the pot will control bass treble and, mid. And since they have a switch when you push on them, they're momentary contact, and they will change the behavior of this. You have several programs, a million colors. So if you ever get bored, if you ever get bored of the color here, you just change it. You can change the speed, change the color, have it just stay on one color if you want, fade in, strobe, all kinds of fun stuff here. It's it's a show bass for sure. It's headless, as you see. The tuners are down here. It is still in the middle of construction. I haven't glued it together yet. This part here will be cut away to reveal this chocolate colored wood here, which is wenge or wenge. Okay, and that's neck through design. This stripe goes all the way down there, all the way down to the end here. There'll be a little cutaway for your fingers there. Yeah, and there's also, you can sort of see the line there. This will be like a chocolate colored against the maple, and there's a similar one down here like that. You can see the line extending here, and that'll be cut away as well. So it'll be like a top on top of a top. So there she is, my super secret project. I've been dreaming this up for about 7 or 8 years now, and being a repairman, I don't have time to work on my own stuff. But thanks to a little extra time at home due to the C-19 virus, we're just waiting it out here. And so I have time to work on my project I've been dreaming about for years. I had a body blank I made a few years before, and it sat around waiting for the right time to complete it. But being blessed with plenty of repair jobs to complete, I never had the time to work on personal projects until COVID hit. The world was turned upside down, and the shop was closed, and I needed something to keep myself busy. My original intent was to build a glued-in neck 4-string, but then I decided to go for it and build it as a 5-string, as I really enjoyed playing my hot-rodded 5-string OLP Stingray. For aesthetics, I was originally dreaming of Jersey Girl type aesthetics, but then I took a fancy to my friend Mauricio's design style. He is the owner of MG Bass Company. His shop was in the same complex where I worked, and we often traded woodworking favors and materials. Many of his designs incorporated double top that I thought looked really cool, so I asked him to scribble his interpretation onto the blank in pencil, and I loved it. I decided to make extensive use of templates, so so I could reproduce every aspect of the design for future builds. The first ones were made from masonite, but then I decided to use plexiglass instead for durability and accuracy. Mauricio had more resources and machinery geared towards production than I did, so he was kind enough to glue one up for me. Over the years, I've seen some pretty cool ideas that I wanted to incorporate into my design as well. Most obviously, the headless design, of course, an end-pin jack instead of the usual jack plate, a no-screw magnetic control cover, fiber optic LED fret markers. Since I originally planned on a glued-in neck, I would need to cut away the middle to make room for the neck through blank, so I went ahead and did that. Next, I needed to cut out the section where the controls would be. I made a template to route out the control cavity. As I progressed in the build, I made more templates for each step to make future builds much easier. Since the saw blade removed material from the body blank, I needed to compensate for that by gluing Wenge veneer back onto the body where I had made the cuts. Next, I installed strong magnets into the body and cover. Then I started work on figuring out how to install fiber optic filament into the edge of the fingerboard. My idea was to use a single 12-volt LED to save power and simplify illuminating each fret marker without wiring a bunch of mini LEDs together. I found out by filing away the outer sheath of the optic cable, it would light up much brighter. On the fingerboard, I made a channel for the cable by using my table saw and painted it bright white to amplify the light. I glued the fiber optic cable into place using epoxy. Next, I clamped the body halves to the neck blank and pulleyed out most of the pickup cavity before gluing them. I finished routing the middle portion of the pickup cavity on the neck blank and routed a pocket for the 12-volt LED unit with a half-round bit. Next, I routed a slot where the optic cable would come out of the fingerboard, into the neck, and into the pickup cavity. I used an extra long drill bit to route the cable to the pickup cavity. I filled most of the entry slot with epoxy and the remainder with Play-Doh as not to get epoxy into the cable channel. Next, I did a few beta tests for the fret markers to know how much pearl pigment is enough. They needed to be translucent enough to allow light through and opaque enough to disguise the optic cable. These are the products I used: a 12-volt 4mm RGB LED driver, casting epoxy resin, Jacquard Pearl X pigment, RGB LED mini controller, 4-pin LED connectors. All these items are readily available on Amazon or other sources. I made a sliding routing jig to route the markers on the edge of the fingerboard. I was careful to route the depth just enough to shave only about 25% of the cable to make it brighter. Then I painted the insides white to disperse the light more evenly. Then came time to tape the outer edge of the fingerboard to hold the pigmented epoxy while it cured. I glued the fingerboard to the neck blank after installing the two-way truss rod. Mauricio rough-shaped my neck blank with its big, scary neck-shaping bit. That saved me quite a bit of elbow grease. Cutting the neck heel was a little scary, since I wanted the heel to have a slight angle to match the shape of the cutaway contour. From there, I final shaped the heel by hand. Next, it was time to mount the string lock. Since it was a little larger than I anticipated, I had to add extra wood on either side to match the shape. I shaped that end with a slight flare. I installed jumbo stainless steel frets. I carefully calculated what the neck angle needed to be and glued the two body sides to the neck. With my router, I created a sled by taping two pieces of wood to either side of the router's extra large router base and carefully routed the excess material from the neck blank almost level with the top. I repeated the process on the back as well. Previously, I had created a hidden compartment using the neck template to install the end pin jack. The cover is hidden and held in place by the tuner's mounting screws. I then routed the end of the neck blank flush and routed a space underneath the tuners for my fingertips. After that, it was time to finish routing for the pickup. With a belt sander, I leveled the remaining neck material. This is the LED controller. I installed it into a tube and encased it in epoxy. Each of these treble, mid, and bass pots are also momentary push-pull pots or push-push pots tapped into the LED controller's circuit board. The volume control is a push-pull pot controlling the parallel series function of the pickup. One battery powers the Bartolini 3-band EQ, the other supplies the LED controller. Using one LED allows the battery to last a very long time.